Hello, yeah, continuing with the Spec B paper for the MAT, and the one that was released in 2009. This is question 2. I might end up doing more than one question because they do seem to have been quite quick in these spec papers. So let's kick off with this one though. Suppose that equation holds for all x, right? So we've got a factorization of a quartic. Find A and B, capital A and B, in terms of lowercase a and b. Right, so we're just, okay, right, this is going to be fair enough. So capital B is going to be easier because we can only get that from a little b squared. And then how do we get x squareds out of all of this? We could have we got 2 lots of bx squared, and then we're going to have a minus a squared. So that bit's fine. Part 2, use this information to find a factorization, because there's going to be a few options for this by the look of it, of this expression. So x to the 4 minus 20x squared plus 16. So we've got that little b is plus or minus 4. So we've either got b is equal to 4, b is equal to minus 4, in which case if b is 4, we're going to have that minus 20 is going to be 8 minus a squared. So a squared is going to be root 28, so 2 root 7. And if we got b is minus 4, a squared will have to be 12, so we'd have 2 root 3. Okay, so we can use either one of those. So we could say with this then that we've got x squared. Let's go with well, again, these are plus or minuses, but they're sort of taken into account by the fact we've got plus or minuses here for a, so it doesn't matter which way round we're doing these. So anyway, where was I? So plus a 2 root 7x, and then plus a 4, and then we can do an x squared minus 2 root 7x, and then another plus a 4. So that's one factorization. Show that the 4 solutions of that equation equals 0 can be written like that. Okay, so we've got this factorization, which is for these, or our other option is to have x squared plus 2 root 3x plus 4. Oh, sorry, minus 4. See, let's not cross that out because that'll just get in the way. So minus 4. And then we'll have an x squared minus 2 root 3x minus 4. Right, so we got those. So our solutions here are, for these ones, we're going to have a minus b, so we've got a plus or minus 2 root 3, then plus or minus the square root of b squared, so that is our 12, minus 4ac, so plus 16, so that gives us the 28. And then we divide by 2. So that is plus or minus root 3 plus or minus root 7. If we were going off of the other one, then we would have minus b, so we've got plus or minus 2 root 7 plus or minus the square root of b squared. So that is our 28. And then we're taking off 16 to leave us with a root 12. Over 2. So we've got plus or minus root 7 plus or minus root 3. Okay, which is what they wanted. Right, so that was a really quick question. So you might as well push on with question 3. So let f of x equal that. Right, so it's split between 0 and 1 and 1 and 2 for x. On the axes provided below, which I clearly haven't copied across, provide a sketch of the graph y equals f of x, right, labelling any turning points and the values attained at x is 0, 1 and 2. Okay, so have we got any negatives? Really, no, we haven't. We're really just looking at a positive quadrant here. So we want to go 1, 2. This is the f of x. This is x. So when x is 0, we're getting 1. So it's going to go through here at 1, and then we're getting 1, 2. So it's going to go up to here at 2 with a straight line. When x is 2, at the other end, we're going to get 8 plus 6 is 14 minus 12. All right, so we end up at 2 again. So that certainly helps because we're going to get the turning point at 1.5 then. So if we've got 1.5, we're going to have a 9 over 4 times 2, so 9 over 2. So we've got 4.5 there. And then we're going to add on a 6 to make 10.5, and then we're going to take off 9 to make 1.5. Right, so we end up going through about here in our quadratic. So that is at 3 over 2, 3 over 2. This is at 2, 2, 2. And then this is at 1, 2. Right, so that's the sketch. So for t is between 1 and 2 inclusive, define g of t as be the integral of f of x between t minus 1 and t. Okay, so we've got a window of 1 that we're moving. Okay, so we've got some kind of window, width 1, and we shift this across, so it could be anywhere in this range. Express g of t as a cubic in t. Okay, so we've got two functions, so we're going to have to split our integral so we know what we're actually integrating. So we've got then the integral of t minus 1 to t f of x dx is going to be the integral from t minus 1 up to 1 of f of x dx. So that's going to be integrating our straight line. And then we can add on the integral from 1 to t of f of x dx. Okay, so this is going to be x squared over 2 plus x between 1 and t minus 1. And then this one's got a lot more going on. So we've got 2/3 of x cubed minus 3x squared plus 6x. And that is from 1 to t. Right, this is going to be a lot of terms. So that's a half plus 1 minus t minus 1 squared over 2. Then it will be minus t minus 1. Then I'm going to have plus 2/3 of t cubed minus 3t squared plus 6t. Then minus 2/3 plus 3 minus 6. Yeek. Right, so how many t cubes have I got? I've just got 2/3 t cubed. T squareds, I've got the one that's going to come out of this bracket and then a minus 3. So this is going to be a minus, what have I got here? I've got a t squared over 2. So minus t squared over, so I've got minus 3.5 t squareds. Minus 3.5 t squareds. How many t's have I got? I'm going to have minus, that's going to be a plus t. Take off that t, they're going to cancel out. So I think I've just got 6t by the look of it. And then for numbers, I've got a 1.5 here. I'm going to have this annoying one here. What's this going to come out as? That's going to be half. Oh, that half's going to cancel with that half. So I've got 2 when I add on that one. And then I've got 5 minus 1 and 2/3. Okay, right, so that is calculate, oh no, express g as t, right, okay, so a slightly unconventional way of writing it, I suppose, for having all of those mixed numbers, but still. And then calculate and factorize g dash, so g dash of t is going to be 2t squared. And then I'm going to have, that's 7 over 2 times 2, so minus 7t plus 6. So that factorizes quite nicely. It's going to be a 2t. I'm going to have a t. I'm going to have the, which way round? I'm going to have the 2 here and the 3 there and make them both negatives. So that's come out all right. What are the minimum and maximum values of g of t in the range t goes from 1 to 2? Okay, t goes from 1 to 2. So yeah, we're going over the full range of all of this. So we need to pick up the extremes at either end. So we need to look at when t's 1, when t's 2, and then whether we've got some kind of maximum or minimum in between those. So we need, right, so let's look at g of 1 is equal to 2/3 minus 3.5 plus 6 minus 1 2/3. Okay, so the 2/3 are cancelling there. So we've got 6 minus 4.5 is 1.5. We've got g of 2, which is going to be 2/3 of 8 minus 3.5 lots of 4 plus 12, and then minus 1 and 2/3, not 1 1/3. Okay, so what have we got on this then? So that is going to be what's that? 2 2/3 times 2, so that's 5 1/3. And then we're taking off, those 12s are going to cancel, so we take off 2, then we take off 1 2/3. So that's going to be 2 minus 1/3, so 1 2/3. Okay, so we've already beaten the 1 1/3 that we had on the previous bit. And then we need any kind of value just in between. All right, we've already done the t is 2, 1 here. So that was one sort of maximum or minimum value that we've got there. And the other one is going to be at t equals 3/2. All right, okay, so at this point here. Yeah, that would make sense, wouldn't it? Because when we've got the window going from 1/2 to 1.5, these are level with each other. So if you shifted from there, then we're going to be reducing either way. Now, you could imagine it having, like, we drew a parallel line from there to there, because that is parallel to our straight line over here. So if we move this window from there to there off to the right, we're going to get a smaller area added here below the parabola than we are here, that we're going to be losing. So we're adding a smaller area than the bit that we're taking off if we move to the right. If we move to the left, then yeah, we're going to have a similar thing going on. So we're going to be adding on taking off more on the left than we are on the right. So yes, that makes perfect sense as to why that is going to give a maximum area when we've got a value there. Yeah, when we've got this value, it's going to be a maximum area. So that's going to come out as being one of our answers. Anyway, let's get back to what I'm doing. So I've got to do g of what, 3/2. Okay, this one will be fun, won't it? So we've got a 3/2 cubed times a 2/3. Right, so we've got 1.5 squared is what we're getting out of that. And then we've got to take off 3.5 lots of 1.5 squared. Okay, and then we've got to add on 6 times 1.5, so we'll add on 9, and then we'll take off 1 2/3. Right, so that's going to be minus. Oh, we got a factorization there that I could do. So that's going to be minus 2.5 times 2 1/4 plus 9 minus 1 2/3. Okay, so 2.5 times 2 1/4 means I'm going to get 4.5 and then another 1 1/8. So that is going to be 5.5 plus an 1/8. So minus 5.5, and then, but I'll be taking off that 1/8 because it's inside the same bracket, plus a 9 minus 1 2/3. So I can take off 6 off of there, which would give a 3. Take off another one, so that's 2.5. So that is 2.5 minus an 1/8 minus 2/3. I think is what I've got on all of that. So 1/2 minus an 1/8 minus a 2/3. So I'm going over 24. So I'm going to have 12 minus 3 and then minus 16. So that's minus 7 over 24. Take 7 off of 48. I'm going to have 41 over 24. Right, so I need to get these other ones over. I've already said that that is going to be a maximum from the sort of blue lines I've scrawled over this. And then the minimum one then is going to be at 1.5, because it's got to be, isn't it? I mean, that's less than 1.5 is less than 1 2/3, so it's going to have to be that. So I'm going to get a minimum when, what have I got, t equals 1, and I've got that g of t is equal to 1.5, and then I've got a maximum when t equals 3/2, and g of t is 41/24. So I mean, if we add, like if I was going to put these other ones over 24, I'll be doing what, 3 times 12 is 36, which is less than 41. So it must be, if I do this one times 8, so 5/8 are 40. So yeah, it sits in between, like 1 2/3 that's 40/24. So that's sitting between. This one is then 36/24. So you can see that they're sitting in between the values that we've got. Okay, that was a bit more substantial than question 2, but yeah, not hugely. I mean, it was mainly just playing around with numbers, wasn't it, and going through your fractions and things, making sure. Can't even remember on this paper whether they let you have calculators or not. I'd hope not. I mean, if they do, then you haven't really got anything to do if you're allowed calculators. So in fact, I'm just going to quickly go and have a check on that. So you're going back and looking at the paper, it doesn't seem to say, so unless I missed it, but still, I mean, there's nothing that you really need a calculator for, but it would make it very easy doing the sums at the end if you were allowed to. So I expect you probably weren't. Anyway, that's the first 2 full questions in this spec paper.